Really quick, just an outline of some of the things we will be covering today. We're going to go over submittals, so what's due coming up March 1st, some general order reminders and regional water board enforcement, along with surface water and groundwater activities. We're going to touch on groundwater protection targets, as well as nitrogen use evaluation. One thing that is not mentioned on here, we will also touch really quick on a new topic, at least it's fairly new. We did mention it last year, but that's the acceptable ranges. So after that, as soon as we get through all those items, I'll turn it over to May. She'll go ahead and finish that out with some really interesting irrigation and nitrogen management content. And she will be providing a survey. I believe that's either will be provided as a link through the chat, or we may just email that after the webinar. I think she includes a QR code for that as well at the end. So those are really important. They help these advisors be able to come and speak to these or speak at these types of events. So we really appreciate if you are able to fill that out, and also it provides some direction. So we'd be really grateful if you're able to do that. Okay, so on farm for March 1, 2025, this is the irrigation and nitrogen management plan worksheet. This is, again, an on-farm requirement. The idea is you start the preseason planning right about now, and try to have that completed by March. At the end of the year, you go back in and you fill in that actuals, and that's that column B you see there to the right lower corner of that worksheet image. So there is a certification component to this worksheet, and for the most part, most of our members are filling these out, or at least have the requirement to be filling these out. The certification, there's a couple options that go with that. One, you can attend the CDFA's self-certification training program. That is an online training program. Takes about 3 to 4 hours, including the test. After that, you are able to sign off on your own worksheets. So you can't necessarily, go out and start filling out your neighbors, unless you're farming that and making some decisions as far as what nutrients are being applied. So all parcels in a high vulnerability area are required to have this certified, or if you are in a low vulnerability area and have had one of your parcels been identified as an outlier. If you're unsure of your outlier status, you can always go to the member portal, check under requirement checklist. It will show you your parcel lines along with that outlier status. Also, a really great and even better place to get this information, because it provides a lot of context, is the nitrogen use evaluation that's also available in the member portal. And we will get into that just a little bit here down the road, but I just wanted to provide some context on that as well. So the INMP summary report, this is what is submitted to the coalition each year. This is an annual requirement. Again, the worksheet, the one we just covered, that is an on-farm requirement. And essentially from that worksheet, the actuals on that worksheet, that is the data that you submit on the irrigation and nitrogen management plan summary report. So it's the same data. The worksheet really just incorporates a planning portion to it. These are submitted online. We used to do paper submittals, but that got quite difficult for quite a lot of reasons. So I won't go into that now, but yeah, For the most part, this is all online, and yeah, I think that just about covers it. You don't need a certification to submit this data. The certification requirement comes only with the pre-season planning portion of that previous worksheet we were just looking at. A quick reminder that all commercially irrigated farmland must be enrolled in the Irrigated Lands Program unless it's already covered under a different general order. This does include irrigated pasture. If you start farming new land or a new lease, please contact the coalition, or you can also use the member portal under member information to add and edit parcels. As far as regional board enforcement, they continue to send out annually directive and violation letters for both parcels that are not enrolled, as well as irrigation and nitrogen management plan summary reports that do not get submitted. If you ever have a question whether you've submitted or not, you can always refer to the member portal, or you can give the coalition a call. We'd be happy to help you there. The regional board on-farm inspections, these started a couple of years ago, and the regional board has continued to select members for on-farm inspections based on non-submittal of the INMP summary report. So besides, maybe receiving one of those directive letters or violation letters, which I do want to mention, if you receive one of those, please, give the coalition a call first thing. We can certainly help you take care of all that stuff. And as soon as we do, the regional board will move on with their day. If for whatever chance you are selected for an on-farm inspection, the regional board usually contacts us. We'll contact you, and we have at least, I believe, 72 hours to get some things in line. So if there are any outstanding reports, we can help you get those reports submitted. And also, we are more than willing to go by your farming operation, do a walkthrough pre-inspection, and see if we can help you out there as well too. So we'd be happy to do both. So just like on-farm inspection notifications and violations for enrollment and the irrigation and nitrogen management plan, or even other reports, that aren't due this year, please always give the coalition a call. Thanks. So if you are selected and the on-farm inspection does proceed, really what they're looking for are listed here on the screen. They have a set of priorities, which again, the farm evaluation, INMP summary report worksheet, that they're gonna want to see recent copies of those. Backflow preventive check valves on wells that need them. Sediment and erosion control. So if you have any sediment and erosion control problems, or you've been identified, your field has been identified as having sediment and erosion control and needs a plan in place, which is a very small amount of our membership base. They would want to see that as well, that you are being protective of any waters that border your operation, any active wells, free of anything that can have a negative impact on groundwater. They really focus in on these wells, as well as abandoned wells. So if you have any abandoned wells, they should be properly covered if they are temporarily inoperable, or you want to contact your county for their destruction process, because there usually is a permitting process that goes along with all that. No violations have resulted from any inspections as to date. So yeah, they've been pretty, regional board anyway, they've been pretty casual so far up in their approach to these on-farm inspections. So we certainly hope it stays that way. And again, if you are notified, please contact the coalition. All right, drinking water. Just a reminder, the drinking water well monitoring requirement began in 2020 for the Tulare Lake Basin coalitions. Active drinking water wells on parcels enrolled in the Irrigated Lands Program needed to be first sampled for nitrates by December 31st, 2020, which was the deadline for the first year of that program. So I will mention that if your well is not active or is not being used for drinking water, you do not have to sample that well. Just contact the Central Valley Regional Water Quality Control Board here in Fresno. They have an office out on East Street. You will find their phone number and email below. You can also do a quick search for that as well and get that. Coalition is also happy to provide you that information as well. So as far as the drinking water domestic well sampling requirements and frequency, the requirement that did start back in December of 31st, 2020, and that continues to be the due date each year. And there are only certain labs that you are able to submit this or these samples to, and those are ELAP certified laboratories. Where it gets a little tricky is with the frequency of sampling after you have started the testing. So if you've been testing for the previous 3 years and your nitrate levels are below 8 milligrams per liter, that goes to every 5 years. So if you did that, you took 3 previous samples all coming back under 8, then you would go to the every 5-year schedule. If you ever test above 10 milligrams per liter, you no longer have to sample that well. Just notify the Regional Water Quality Control Board. There is also a notification template to provide any residents that may be living in that or using that domestic well. If it's you or your family, you don't have to provide a notice to yourself or your family. Unfortunately, the worst place to be is that 8 to 10 range. So that just keeps you sampling annually until that number kind of moves up or down. There is a drinking water alternative delivery that you can apply for through the King's Water Alliance. That link is down there. You can also, if you want more information on that, please call the coalition. We'd be happy to direct you there, okay? So this map highlights the areas where we take samples off of the Kings River and a few additional waterways. During 2023, there were a couple management plans triggered. One for E. coli. So we got a positive result on there, over the limit there. And that was found at Cross Creek. So you'll see that kind of down here at the southern part of the coalition, or middle, I guess. Also Stinson Weir up to the northwest. And then we had Tybee Creek, which is all the way up there in the northeast quadrant of the coalition's boundary. It's that little blue dot up there. There was also a hit for dissolved copper, which can be harmful to aquatic life, and that was also found at Tybee Creek, which would result in some additional member outreach around that area and a surface water management practice implementation report. You may be familiar with the groundwater management plan implementation report. So it's very similar to that, just regarding surface water. These are the results of our 2023 groundwater well monitoring. So we do annually monitor groundwater wells, a network of about 48. And we do look at that data and try to discern trends from that. So during the 2023 sample, we found that there were 7 wells that were decreasing as far as their concentration of nitrogen. 10 increased, 1 stood stable. There was 21 that had insufficient evidence. So through their analysis, they just weren't able to get a slope on that data, and there was no trend that was able to be flushed out from that. Also, 9 wells just did not have enough samples yet. So I believe we have to have at least 5 samples to start looking at a trend of any given well. All right, we're gonna switch over to the groundwater protection targets. I believe we covered this last year a little bit. The purpose of the groundwater protection targets are to define nitrogen loading average in pounds per acre at the bottom of the root zone to comply with receiving water limitations. And that's after considering other relevant post root zone processes. So after it leaves the root zone there, what are the processes that are taking place that are facilitating or inhibiting that nitrogen into groundwater? The calculation of groundwater protection targets requires integrating the groundwater protection values, which I will get a touch on here in the next slide. Its groundwater protection values they estimate from irrigated agriculture into the broader Central Valley hydrologic system to understand the effect of current agriculture management practices on groundwater quality. Okay, so I'll get to the next slide in a second, and maybe that'll answer some questions if you do have any. Essentially, they're taking the hydrologic system here in the valley, looking at just not irrigated ag, but dairies, industries who may be on a individual permit, or directly with the water board. And after they take all of that into account and figure out or estimate what the nitrogen in pounds per acre being lost after the root zone, then they can take that number, integrate some of those post root zone processes, and try to estimate what is directly affecting the groundwater. This is the map that I was just referring to. So you look at the left side of this image, it shows load estimates, and the right side of the image shows the prioritized load reduction in a township. So milestones are intended to assist growers in working towards achieving ultimately the target, the groundwater protection target. And the target is what complies with receiving water limitations. So these milestones are really just, like it says, a milestone along the way to the groundwater protection targets. And you'll see, if you look at that legend, there is a red box with some slashes through that. Those are townships who already have have been estimated with a nitrogen concentration of 10 milligrams per liter towards receiving groundwater. So you'll notice that those townships are not on the milestones. obviously they already meeting that receiving water limitation. All right, we're going to switch gears here a little bit. We're going to move over to the nitrogen use evaluation. This is a report that is provided to our members each year, and this year we're a little late getting those to you, so I do apologize, but you should have a notification here pretty soon when those are ready. We will provide you with a direct link to the member portal to view that entire report. It is quite a lengthy report, so it is fairly difficult to mail the entire thing. In the past, we did mail out a summary of this, which we found was a little confusing, not having all the context there. So if you're looking at this report, what you will see is, or one of the more important parts, I would say, is this outlier analysis and the 3-year analysis. So they do take into account 3 years to try to remove any variability through fields. So if you have one bad year, it's not necessarily going to affect you there. So the evaluation does use what's referred to as applied nitrogen over removed nitrogen as a metric for essentially measuring agronomic efficiency. Okay, so currently the threshold, or you'll see just directly to the right of that 3-year applied in over removed, is the outlier A over R. So that is a number that is taken from all the other growers with the same crop and similar practices. And essentially, if you are outside the normal range, then that parcel could be considered as an outlier. And again, outside the normal range, typically for 3 years. Directly to the right of that outlier, A over R, is the 3-year total applied in. So that's just the amount of nitrogen applied in total to that field over 3 years. To the right of that is the 3-year removed N. So this is what is thought to potentially be taken up by the crop over that 3 years. And then the last column there is that A minus R. Again, that is a 3-year A minus R. And that is just applied nitrogen minus removed nitrogen. And that is probably one of the more useful numbers if you're just looking at it from a grower standpoint. That gives you an idea of potentially what is being lost as far as nitrogen not being taken up by the crop, and then potentially being leached into the groundwater. So parcel outliers, they may be required to complete additional INMP training. So if you're self-certified, you may have to attend additional trainings on that. Or if you're in a low vulnerable area and you haven't been already certifying your plans, you may need to attend one of those courses or use a professional. So, but if you ever get that outlier status and you think it's wrong, or you have questions about it, we're more than happy to kind of go over all that stuff with you in detail and take a look at your operation and see how we can help. All right, we are going to switch over to another topic. These are crop-specific acceptable ranges of nitrogen applied relative to nitrogen removed, or commonly referred to as AR ranges. Acceptable ranges, they also use that metric of applied over removed. And that is to help prevent over application and loss of nitrogen to groundwater, and just like we discussed. They do help growers improve nitrogen use efficiency across different crops, and this is by reducing the risk of nitrate leaching into the groundwater. So they are pretty useful as far as trying to figure out how efficient your nitrogen applied is to your operation. By optimizing nitrogen applications, growers can potentially cut costs. Ranges are based on a combination of multi-year data collected from growers, peer-reviewed scientific research, and real-world growing conditions found here in the Great Central Valley. This helps ensure they are both accurate and practical for growers to follow. So these will be coming down the pipe here in the next year, maybe two, and I'm going to cover some additional information in the next slides. But just so you know, this isn't being applied yet. It is still being worked out. I believe we're waiting for an approval on these ranges by the Regional Water Board. This slide explains the background and regulatory framework guiding the development of crop-specific acceptable ranges for nitrogen applications relative to nitrogen removal. So just like members, you have requirements, coalitions, we have our own requirements, and we are required to develop a management practice evaluation program, which has been in the works for quite a number of years now, at least 10 that I know of. The MPEP does evaluate the effectiveness of management practices in reducing waste discharge from irrigated lands to groundwater, and taking into account all the variabilities that entails. Some of the key objectives to meet this requirement. The MPEP did focus on two main goals: determining crop-specific coefficients to measure nitrogen removal in harvested crop yield. So a lot of research has been going on up at UC Davis. You may be familiar with the Daniel Geisler report. There is a fairly current version of that we will be hosting on our website. I'm sure we'll probably provide that in some email at some point as well. And the second was establishing acceptable ranges for the multi-year A/R ratio for each crop. So that applied over removed ratio. So right below that, you will see State Water Board guidelines. And some of this language is pulled directly from the state's language, and it is essentially what their directive is referring to: a metric for evaluating improvements over time, and also a tool for identifying outliers. So essentially replacing the N thresholds that I just discussed in that previous slide on the nitrogen use evaluation. So potentially and probably replacing that metric there, which I certainly assume it would. So for more details, we do have the full report available. We don't have it publicly available on our website. We are working on a landing page for this acceptable ranges report. You can follow this link here in the slide. We will put these slides up on our website, so you can get access to it that way. And Vincent Sombrano, a lot of you may know him here from the coalition. You probably work with him quite often. He's one of the point contacts for a lot of the member calls. He may be kind enough to go ahead and chat that link out to all of you. So in essence, the AR, or applied nitrogen over removed ranges, provide both a benchmark for growers and a pathway for improving nitrogen management practices over time, ensuring sustainability and compliance with water quality regulations. Right, I think we're doing pretty good on time here. This slide also digs into the acceptable ranges. It highlights the key aspects of applied over removed for the ranges and some of their significance for growers. They are meant to help guide growers in achieving nitrogen application levels that match their crop's needs, which brings with it, obviously, potential cost savings, as well as protecting groundwater by reducing nitrogen leaching. So how it works, obviously there's a range. The lower end, that represents the smaller AR ratios. So lower end, you think smaller ratio. And these are thought to be achievable under optimal growing conditions. This is the target for high efficiency. So everything goes perfectly. What's that ratio you're shooting for there? The upper end accounts for larger ratios that reflect real world conditions, such as pest pressures or varying soil types. These are designed to be achievable under average conditions while minimizing environmental risks. So again, these are still coming down the line, but some ways you might use these AR ranges. You can look at your INP data, check if your A over R ratios fall in the acceptable range for your crop. Again, that information will be available in the full report that we will have available on our website here in the coming weeks. If your ratios exceed the upper range, consider adjusting fertilizer applications or other practices to align with the recommendations. All right. So if you have any questions, please feel free to chat those in the Q&A. We'd be more than happy to get you a response there. You're also welcome to give the coalition a call. You can send us an email if you have any questions. And we will be making some virtual appointments available. We started doing this back in the COVID days. We've kept up with them. I don't believe I've made those available yet, but we will have those up here within the next couple of weeks at latest. Okay, so you can always utilize the virtual appointments if you are comfortable with Zoom and you would like an interactive appointment with staff here at the coalition. So with that, I will introduce Dr. May Cullenber. She's a nut specialist with the University California Agriculture and Natural Resources. I do believe she's available. She may correct me through parts of Tulare or Kings County also if your farm is there. So I will go ahead and turn that over to her. I appreciate your time and thank you very much.
Thank you, Jarrett, and thank you everybody for coming today. So I've been asked to talk about the relationship between irrigation and our nitrogen management, and how we can achieve better nutrient efficiency when we're, understanding the relationship between those two. And to sort of illustrate some of the things that I'm going to talk about today, um, we can think about irrigation and farming systems that are highly efficient, are going to maximize crop uptake. So nitrogen is a really dynamic um, chemical in the soil and the water, and so it can exist in a lot of different forms that can be susceptible to losses if we're not getting good uptake of the crop. And so Jarrett, we're mainly focused on leaching losses. But then there can also be losses through volatilization and denitrification or potentially runoff and erosion. And so, a lot of it depends on the type of fertilizer that we're using. But when we have a poor efficiency, we're not getting optimal crop uptake, and we're likely getting larger losses to one of those pathways for loss. So, but leaching tends to be the one that we're the most concerned about, especially when speaking about, potential contamination to the groundwater. And the reason that is because if we have excess nitrogen that's in the root zone that is not taken up by the crops, um, eventually all of that nitrogen, the nitrogen can be in a lot of different forms, but eventually it's going to convert to nitrate. And nitrate is more susceptible to leaching because of some of its properties. Nitrate has a negative charge. Our soils are generally also have a negative charge, and so they oppose each other. So nitrate is not easily absorbed onto the soil. You'll see in the picture here, we have an ammonium ion that is drawn to the soil surfaces. So when nitrogen is in the form of ammonium, it doesn't move as quickly through the soil profile. But when it's in nitrate, it doesn't adhere, and it's easily lost when we have drainage going through the soil. So this is an outline of some of the things I'm going to go over, different factors that influence nitrogen use efficiency. And first I'm going to talk about our irrigation system distribution uniformity and efficiency. And so this is actually looking at distribution uniformity, tells you how efficiently your irrigation system is running if the output is the same at different parts of the field. So if you're familiar with your irrigation system blueprints and that from when you set up your orchard, there's a lot of specs on there that tell you what the output should be for each emitter. But with wear and tear, over time, when clogs start to form, we start to see reduction, usually in efficiency. And so one of the services that we offer with the university is that we can do what's called a distribution uniformity test. And so we can look at different parts in the field and see how well the output matches at different places. And so basically when we talk about distribution uniformity, that refers to the ratio of the lowest performing emitters, so the lowest quarter of measurements, divided by all volumes that are measured. So that gives times a factor of 100, gives you that DU percentage that you often hear about. And so this table illustrates why it's important to have a high distribution uniformity. So usually when, especially with micro irrigation systems, they're highly efficient, newly installed, they're going to be probably between 90 and 95% efficient. But with not keeping up with the maintenance or just normal wear and tear, we're going to see reductions in distribution uniformities. So I was telling you in the earlier calculation, thinking about the lowest quarter. So the lowest quarter is going to be those areas that are the least efficient. So in this example, if the target was to apply an inch of water, at 70% efficiency, we would only be applying 0.7 inches rather than the inch. But at the high quarter of the field, when we have 70% efficiency, there could be some emitters that are applying as much as 1.4 inches. So there can be quite a wide range. So it's not just that they're under applying, but they could be greatly over applying. And that might not seem like much of a difference from 1 inch, but the difference across one irrigation set is here. But then think about that multiplied by 30 irrigation cycles over the course of a season. You could be applying, you know, as much as 15 inches more than what you would have applied with a 90% distribution uniformity rating. And these pictures further illustrate that concept, that, you know, if we have different parts of the field that are receiving more or less water, um, you know, there's, and think about this in with respect to fertilization, you know, we might be pushing fertilizer past the root zone in areas where we're getting too much water and then maybe not enough water, excuse me, maybe not getting enough water in other areas. With the new system, you can have high distribution uniformity, but we need to make sure that we're having good irrigation scheduling, as precise as we can, because if we're over irrigating, then we're not efficient across the board, which would be the middle drawing here. And then, you know, what the goal is to have good distribution uniformity with good irrigation scheduling. That's going to give us even nutrient application and retention throughout the root zone. So we're going to keep the nutrients that we applied in the root zone for long enough for the crops to take up what we've applied. Sometimes aerial imagery, some of you might be using that technology. That can be a really good indicator of what the DU is like in your field, and can also tell you, you know, overall what your irrigation efficiency is like. So in this picture here, the blue areas are likely receiving more water and nutrients than what the crop requirement is. And those areas seem to correspond with probably where the risers are. So there's a difference in output closer to the riser compared to the far ends of the field towards the end of the lines where you see that there's red, which indicates that there's insufficient irrigation and possibly insufficient nutrition as a result. So, you know, to maintain good distribution uniformity, we've got to keep in mind that these micro irrigation systems have really small emitters, and there's openings. If we're having issues with water quality, are highly susceptible to clogging and leaks. So you need to make sure you're doing routine inspection and maintenance, examining the nozzles and the wetting patterns are, you know, a good indication just driving around of where there's problems. So just make sure you're flushing lines and cleaning filters on a regular basis. And then if you install and check flow meters, you know, that's a great way to look at your overall water use through the course of the season, see if it matches what you intended to apply. And then a lot of the subscription services that might provide you with sensors, you know, they have the option to have an inlet pressure sensor so that you can see, you know, you should know generally what pressure the system should be running at when everything's going as it should be. So you could ask to install, or you could install an inlet pressure sensor. And I forgot to mention earlier, that's something else that we look at when we're doing these evaluations, is not only the output of the emitters, but just the inline pressure at different spots in the field. Okay, so another thing to consider is your soil texture with irrigation scheduling. And our irrigation systems are most efficient when the application rate is going to match the infiltration and permeability of the soil. And there's a lot of different factors. So soil texture is a big one that I just mentioned. And soil texture is going to affect the pore size and how easily water moves through the soil, and how much at a given time. And then texture and the organic matter content of the soil is going to determine how well the soil aggregates, so forms clumps that allow for pore spaces to be developed for water to flow through. And then, you know, if you have cover crops, in the middle, or even the plant roots from our trees or whatever crop it is we have our out there. That's going to allow for it's going to create channels for water to flow down through the soil. Our cultivation practices can have a big role. Initially when we cultivate, that can break up the soil, and allow for water entry. But when we cultivate, that tends to disperse the soil structure. When the soil settles back down, that's what leads to surface crusting, or hard hard pan layer a little bit below the surface of the soil. And then also the water quality and soil characteristics. If we have salts, that can also affect the flow of water. So again, with texture, so the storage capacity, and this is going to relate to a little later, if I can get to it. I'll give you an example of irrigation scheduling with keeping your soil texture in mind. And so you might want to think back to this graph later that shows different volumes of soil water that can be held depending on your different soil texture. And so our sandier texture soils, they have larger, coarser fragments, and so they're an order of magnitude or more larger than your silt and clay particles. So cumulatively, a clay, so even though the clay particles are much smaller, cumulatively in a volume of soil, you're going to have a much higher surface area. So there's going to be more water retention in clay textured soils. And so this just illustrates that point, that with more clay textured soils, you have higher water holding potential, and you're actually going to have somewhat lower permeability, so the rate that the water flows through the soil, in comparison to a sandy texture soil that has larger pores, is going to allow for faster movement of water. And so that texture is also going to affect. Again, this is just another illustration showing water holding capacity. But when we're thinking about irrigation scheduling, we're going to be thinking about what is the moisture content at what's called field capacity. So that's when the profile is full and it's not saturated because enough water is drained away, that there's still oxygen in the soil. But this is after saturation, the water drains away, but it's full profile. So going from there between what's called management allowable depletion, and that's the point when the soil is still holding water, but it's becoming a little enough that the plant is starting to come under stress to extract the water. And so when we're managing for irrigation, we want to keep our profile to the extent that we can between field capacity and this management allowable depletion. And so with the micro irrigation system, something else to consider is that with your different soil textures, you're going to have different movement of water, either laterally from the emitter and with depth down through the soil. And so a clay soil, the same volume of water, same set time, water is going to move in a heavier clay texture soil more laterally compared to a sandy texture soil where you're going to get more straight downward movement. So it's good. It's important to consider the percent wetted area that's influenced by your irrigation system and your soil type, so that you can avoid over irrigating in the sense that you're pushing water below the root zone. So in a sandy textured soil, we might need to be doing more frequent irrigation sets to keep water the best we can above the majority of the roots. So something really important to consider with our nutrient applications are when other tree, trying to match that application with when our crops are taking it up. And so Jarrett referenced the nitrogen recommendations put out by Daniel Geisler. And I believe that some of these profiles are in there for different crops. You can see, what the timing is of uptake and how it corresponds to crop development through the season. And you can see from this example, this is for almond, and then the one on the right is pistachio over a 2-year period, kind of showing the difference in nitrogen demand between an on year and an off year. But that uptake rate is going to depend on the concentration that's available to roots in the soil, and then the demand by the plant for that specific nutrient at that time. And almond bloom's right around the corner. And so everybody's, gearing up to start with another fertilization season. But it's good to keep in mind that from from research, we understand that at flowering, fruit set, and even up to early leaf emergence, nitrogen is provided to the developing fruit from remobilization of nutrient reserves from roots and perennial wood biomass. So initially, when the tree's coming out of dormancy, it's not immediately taking up nutrients from the soil. It's actually in the stage where it's remobilizing from its perennial tissues. And then when we get further along with leaf expansion, maybe mid to late March, that's when our root growth starts to accelerate. The reserves that the tree was utilizing to, come out of dormancy are depleted, and then that's when soil nitrogen uptake starts to increase rapidly. So if we were going to follow along with that graph I showed before, and this is another example of almond tree nitrogen uptake, and our understanding of when that uptake occurs. And if these green bars represent, a hypothetical fertigation, you would do more frequent applications to match this uptake. And so I think this is, maybe counter to what, is a standard practice for a lot of folks. But this pattern will be what we would call high frequency, low concentration fertigation strategy, and has been shown to increase nitrogen use efficiency in almonds. So looking at this graph, by about 100 to 126 days after full bloom, that's when the kernels around this stage right here, probably about early to mid-June, that's when the kernels have gained about 60 to 70% of their total weight. And then the fruit nitrogen accumulation begins to, flatten out at that point. But this might be, more of a common fertigation approach. But, and a lot of times fertigation likely starts, right around bloom, maybe mid to late February, in a few shots, and then with the majority of the applications finishing off by about mid-May. And then oftentimes a post-harvest shot is applied with the idea that, this is the time that buds are differentiating. The trees have been very stressed. So we're going to put some water and nutrients on. In this presentation, I'm not going to go into a lot of detail about leaf tissue sampling, but I would say that the research is kind of mixed on how effective this is for helping for next season's crops. So we advocate for sampling in midsummer, doing the leaf tissue sampling in midsummer, and see, if where your levels are at, and if you're, in the sufficiency range, maybe you could evaluate whether you want to put on maybe a small application or just hold back if you're on the high end. But if you're deficient, maybe the trees will benefit from that late shot of N. And just to illustrate this point on making the consequences of what large applications can do, a couple springs ago, I visited with a grower that they thought they might have phytotoxicity from an herbicide application because they were seeing a lot of scorch in the canopy and there was a lot of nut drop. And this was about mid-April. And just about 2 weeks before, they had shanked in about 50 pounds of UAN into the soil, and then they followed that by a flood. Um, and then they had these scorching symptoms soon after. Um, something that's really diagnostic of the nitrogen burn is that the foliage recovers. So in this picture, you can see, it might be hard to see, but there's scorch, a little further down the branch, but then the new foliage coming out was fine. And so sometimes that's really diagnostic or characteristic. A lot of times the leaves will be just kind of, sort of weepy looking. So, we need to be careful. You don't want to apply too much in a single shot. It can burn your tree roots and leaves and potentially cause nut drop. Um, and then, you know, a lot of water availability is, always dirt matches peak runoff times. And so that could be the early spring months, or even a little later in spring when, thinking about that chart that I just showed when we do a lot of fertigation. And so, this is a difficult issue because, if we're trying to recharge the groundwater, we're going to be putting water out, but you need to make sure that if you're doing those applications, that it's not coinciding with a nitrogen application, because that's really going to increase the loss of nutrients from the root zone. And this chart sort of illustrates that. This is actually just a simulated analysis for corn, but I put it in here because they looked at a number of different application rates with the same amount of nitrogen. And so they looked at that high frequency, low concentration application where every time they had the water on, they were applying a little bit of nitrogen. They had weekly fertigations, they had twice monthly fertigation, and then monthly. And then this graph is showing the amount of deep percolation of nitrogen, so nitrogen going deep in the root zone, in comparison with the amount of water applied. And so what this shows is that that high frequency, or just injecting each time the water's on, and the weekly applications had a little bit lower deep percolation compared to, say, a monthly or a twice monthly application. But overall, it was really the amount of water that was applied that was really driving that deep percolation. So, there may be some benefit with those more frequent lower concentration applications to match uptake, like I mentioned, but overall, it's just this is where that relationship between nitrogen and applied water comes in, is that if we're applying a lot of water, that's when we tend to see losses of nitrogen from the root zone. Okay, so fertilizer timing. So I just have a couple slides about this, but this would have to do with just timing during the irrigation set. So these graphs are from a study that was conducted in a loam soil with drip irrigation. And the graph, the vertical axis is the depth in the soil, and it's in centimeters. And then the x-axis is the distance from the emitter going out laterally. And then the different colors show the different concentrations of nitrate in the soil. And so they did 3 different timings for the injection. They did an injection that was right at the beginning of the irrigation set, and then they did right during the middle of the set, and then the end. So basically what this shows is that if you apply right at the beginning, you're going to get most of the material applied is going to be pushed down. So, between 2 feet and lower. So just from that one irrigation set, so you can imagine whatever the crop doesn't take up, by the time you apply the water the next time, it's going to push down the nitrogen even further. Applying it towards the end of the set, it was pretty shallow in the soil, so in the top, probably a foot or so. And then applying in the middle, had the best distribution um, in the root zone without pushing it too far down. So generally speaking, it's this is really soil texture dependent, but generally speaking, injecting in the um, towards the middle of the end of your irrigation set is generally what is recommended. But again, your soil type and permeability is going to make a big um, difference. Also, just your irrigation system, knowing how long it takes for the chemical to travel from the injection point to the far ends, because you want to make sure, you might remember back to that series imagery I was showing, the trees at the far end of the reach, they seem stressed. I don't know if it was water or potentially nutrients too, but you want to make sure you're accounting for the travel time. This is a little complicated calculation to do. Some other research has looked at, using dye injectors to see how long the travel time is from when you start the injection till it gets to the end of the irrigation line. And then this is also really useful to figure out how long do you run the water after you've completed the injection, so that the fertilizer is no longer running in the lines. Because going back to the talking about maintenance and everything, residual fertilizers, especially ones that have calcium in them, if we have high pH, if we have a lot of bicarbonates, that can cause the development of precipitates and scale. And add to some of those clogging issues. So we want to make sure that we're have good timing for how long we're going to flush. So afterwards. And so another easier way of doing that, and something that my staff research associate Ben Halick and I are investigating, is using electrical conductivity meter. So the fertilizers have a little bit of salt in them, so they're going to raise the EC of the water. So we're working with a grower in the Selma area to help him figure out, when is that optimal injection time, and how long to run the irrigation system after. So if that's something you might be interested in, let me know. Okay, now irrigation scheduling. Um, so there's three main methods or tools for irrigation scheduling that you have probably heard through a lot of these extension type talks. So there's water budgeting. So water budgeting consists of comparing your evapotranspiration, so that either this in this chart, it says ETC, so that would be the estimated evapotranspiration. So maybe referencing a CIMMYS weather station and then applying a crop coefficient to estimate what the water use was. And so we would compare that with the amount of applied water and in-season rain, and how much moisture the soil can hold to come up with a water budget. Soil moisture depletion, I'll show a few graphs looking at that. Being familiar with just the behavior of the soil moisture depletion, and using that to determine, okay, like we've reached a threshold, it's time to irrigate. But it's also good to verify what those sensors are telling you with, just augering or using a shovel and doing texture by feel, because the area of influence that we get from the soil moisture sensors is very small. And so it's maybe potentially not representative of what's happening in the rest of the field. And then, understanding what the plant water status is. So using either a pressure chamber, or now there's a lot of automated type equipment that can tell us, are the trees well watered, or are they suffering from stress? So with the water budget, it can be complicated to track. So Jarrett mentioned earlier that there's a crop manage program, that there's going to be a training actually on January 29th at Kearney, if you're interested. This is a software that helps track the information for you. So if you create a profile and it knows the location of your farm, it will just, it inputs on its own the evapotranspiration data from the nearest CIMA station. If you happen to have a weather station that you would like to use that data for, you can input that. We can reference that data. And so it takes that information in and it makes a weekly recommendation to you. You tell it how old your trees are. You know, you can add information about yield, nutrition, everything. And so that's how it makes a calculation of what the recommendation might be, and then it helps you track from 1 week to the next how much you applied versus what was recommended. And so if you're interested in learning how to make a profile and use that program, like I said, January 29th, there's going to be an opportunity at Kearney Research Station, and you just need to bring your laptop. Okay, so I'm just going to wrap up with just talking a little bit about how you would figure out what the maximum amount of water you would apply in an irrigation, just based on your soil texture and an estimate of what your effective rooting depth is. So we know with permanent crops that the rooting depth is quite deep, but when we talk about effective rooting depth, that's the roots in the top part of the root zone that are taking up the majority of the water and nutrients. So we tend to think of that for permanent crops to be about the top 3 feet of the soil. And then again, I mentioned that management allowable depletion, we'll take that into consideration. And then the irrigation, the efficiency of the irrigation system. So this would be, those are the components of what you would use to determine how much you would apply in a single set. So just for example, we'll say you have a sandy loam soil, and there's a lot of references, tables out here. Here's an example of one from the Bureau of Reclamation that'll tell you in general, you know, how much moisture, how many in inches of water the soil can hold per foot of water. So in this table, it's 1.2 inches per foot of soil for sandy loam textured soil. Something else important to know is what the output should be. So if you haven't had a DU test, you could just put in what the intended gallon per hour is if you have emitters, the flow rate, and then how many emitters are per tree, and then how many trees per acre. And then that'll give you, if you know, because sometimes it's, you know, just making that conversion between inches per hour. I keep mentioning inches with like that ET. We tend to express that in inches, but you know, a lot of times people are more familiar with the output in terms of gallons per hour. So this calculator listed here can help you make that conversion. Okay, so back to that calculation. So we've got the amount of water applied. So remember that management allowable depletion, that number can change, but generally speaking, most crops, we tend to think they're around 50%. And then that 1.2 inches of moisture per foot of soil. And then remember, we were saying that we're going to manage for the top 3 feet, that effective rooting depth. And we'll assume that the system is 95% efficient. So if we take that MAD, the management allowable depletion, divided by 100, we multiply that by 1.2 inches by 3 feet, and then divide it all by 95%. That's going to tell us that for a single irrigation, you don't want to go beyond applying 2 inches of water, so no more than 2 inches. So now if we know what our application rate is in inches per hour, so go back here and you put in, you know, we determine based on your emitters and the gallons per hour what the inches per hour output is. So if we divide that 2 by 0.05, that's going to tell us that we don't want to exceed an irrigation set time of 40 hours. Otherwise, we're going to be pushing water below that 3 foot root zone. So you know, this might just be something important to consider, especially when we're applying fertilizers, just because we don't want to, you know, push the moisture too far down. So just a, you know, a little calculation to help you. So, but, you know, different situations are everywhere. And you might have problems with infiltration, just because of your soil texture. There may be some chemical things that are slowing down water flow. So it might be necessary for more frequent sets to avoid runoff. Um, or, in the heat of the summer, you might need more than a 40-hour set to meet your ETC requirements. Um, with the ETC, I mentioned that Crop Manage, we also offer a weekly email report that goes out on Fridays that uses the SIMA stations to determine, what the ET has been. And so we do this for a number of different crops. We got almond, pistachio, citrus, raisin grapes, wine grapes, walnut, stone fruit. And what the report gives you is what the calculated amount is based on last week's weather. Um, and then it gives you an estimate of what the accumulated season water use has been um, for the season, and then an estimate of what the water use is going to be next week. And we make that prediction based off of the 30-year average, and then also in the last few years, we've been increasingly using the National Weather Service. It's called FRET. They provide an estimate of ET prediction for the week. So we factor those in. And so you can look at these two numbers and say, okay, for almonds in Parlier, last week was 2 inches, predicted to be pretty close to the same for next week. So maybe I need to apply 2 inches to refill the profile or refill the water demand. And then, using all those same numbers as before, you can use that information to figure out how many days should I go between irrigation sets. So sometimes I get that question, like how many days would be optimal to go between. So again, take into account the MAD, 1.2 inches per foot, the effective rooting depth, and that tells us that the soil moisture at field capacity for the top 3 feet is going to be 3.6 inches. But we only want to lose half of that before we would trigger another irrigation. So we've only got 1.8 inches to play with. And so if we got this weekly report and we know that in the heat of the summer, if it's 2.1 inches for the week, then we know we're losing 0.3 inches per day. We can divide that 1.8 by 0.3, and that'll tell us that there's been you have 6 days between finishing irrigation and management allowable depletion. So don't go more than that many days, but again, you're going to ground truth that and check plant water status and everything to make sure that that's not too far apart. Sorry, I meant to turn off these animations. So just I'll wrap it up here in a minute. I just want to tell you a little bit about soil moisture sensors. So there's a lot of different units out there available, but basically the readings are going to be in a few different units. Some of them give you the percent weight in terms of the weight of the water per the weight of dry soil. Other ones are volumetric. They'll tell you the volume of water per volume of soil. And then there's some that tell you what the tension is. So that those readings are usually in centibars or kilopascals. So that's telling you how strongly the water is being held by the soil particles. And so when we're near saturation or just after irrigation, there's less tension. So the tree is having an easier time taking up water, but as the water depletes, the water that's remaining is held increasingly tightly to these soil particles. So that's why the tension increases. And so we know what the values are that correspond between tension and moisture content. And so grower and Parlier, and just wanted to show you a few different profiles. So his sensors give him soil moisture percentage. And so depending on your soil texture, this would be the soil moisture content of soil that has moisture. And so when you are at that 50 depletion, that's going to be the trigger for refilling the profile. So we have different soil depths. So this is a 4-inch depth. So you can see that that dries down really quickly between irrigation sets. But if you look at like the 12-inch, this grower's done is doing a good job of keeping the irrigation on. The moisture profile, even at the 12-inch, was, even after drying down in between irrigation sets a little bit, was still staying pretty moist, near that 20% desirable content for a loam textured soil. So, but other sensors don't give you moisture, that same moisture content. They might have a relative number that's going to indicate 50% depletion. So you might just see on a sensor that there's a 0 to 100 number. So 100% would represent the moisture level at field capacity. So that's not going to correspond to that same table I showed in the last graph. But this just shows for different sensors that, so at this arrow is pointing to, at this point here, the 6-inch depth was at 50%, the 10-inch was about 53. And so, just those top two sensors drying down to about 50% of the desired moisture content triggered an irrigation. And then here's just an example. These aerometers, or watermarks, or what's in the picture here. And so again, those read intention. So the lower the number, the less stress. And the threshold, I didn't include this table, but this is going to change depending on the soil texture. But again, it's just the same principle. You likely have sensors at different depths, and you'll know, at a certain centibar, depending on your soil texture, that's going to represent that 50% depletion and is going to trigger or tell you it's time to irrigate. But again, really important just to ground truth it by hand. If you're interested, there's, some scientific method to soil moisture texturing. And so you can Google USDA estimating soil moisture. And so depending on your soil texture, there's kind of a step-by-step guide that'll tell you, how well you can make a ball, how much of the soil remains on your hand, things like that. You can actually estimate a percentage of moisture content if you get really good at it. Okay, so last thing is just this, the plant water status indicators. So, I was just talking a lot about water budgets and soil moisture. Those measurements don't indicate how well a tree responds to that applied water schedule. And so what we call midday stem water potential, it quantifies how the trees or how the crop is responding to the soil and water and climatic conditions. So it can confirm your assumptions. So say you use some of those, just really basic calculations on how much water, how much water you can apply at once and how many days you go in between. You can use something like this to ground truth and say, yeah, the trees seem happy. So basically this is like, it functions like a blood pressure reading. So we know, what level of tension a well-watered tree should be under, and we know that, when it gets to a certain level of stress, if we're measuring, if it gets beyond a certain level of stress, that indicates that there's some water stress going on there. But those can be complicated. Maybe not so much complicated, but labor intensive to use these, especially if you're managing a lot of different orchards. So, there's a lot of automated plant sensors out there now that are available. I was involved with a study looking statewide at almonds and how well, those stem water potential readings that I just was just telling you about compare with some of these automated sensors. And there's pretty good agreement between, some of these new microtentiometers that are on the market that are actually they're embedded into the connective vascular tissue of the tree and give you a continuous stem water potential reading. So, there's some great technologies out there that seem really promising. So just wanted to share that with you. And okay, so in summary, uh, you know, irrigation system distribution uniformity and efficiency is really important. If you have good DU with good irrigation scheduling, that's going to mean even nutrient application and retention in the root zone to maximize uptake. It's important to consider your soil texture for considering irrigation set times to avoid leaching. Um, get the resources to find out about the crop uptake pattern dynamics and apply nitrogen and irrigation to match uptake to increase efficiency and minimize losses. With fertilizer timing, more frequent small injections seem to result in less leaching than large infrequent doses. And with your irrigation scheduling, deep percolation by over irrigation is going to be the largest factor that's going to drive nitrogen losses. So, we want to, particularly when we're fertigating, you want to keep water nutrients in that effective root zone. And so use a water budget or plant water status measurements to increase your scheduling precision. And with that, just wanted to make a plug. I'm involved with what's called the Nitrogen and Irrigation Initiative. So it's a collaboration with some cooperative extension advisors and CDFA. And so, we're just trying to increase the resources available to you. I mentioned the DU, I mentioned the looking at the chemical travel time for fertigation. We can do on-farm consultations. You can also get your INMP credits with a 1-hour consultation. So here's my email. I'm serving Fresno, Kings, and Tulare through this program. There's other advisors in other areas, so please reach out to any of us if you'd like some assistance. And with that, we're also, would just really appreciate your feedback. Maybe about this talk or just your experience with cooperative extension in general. But yeah, this, it's a quick survey, just a couple questions, multiple choice, and it would just be really valuable to us to help us, improve our services to you. So I think Jarrett also provided this maybe in the email, but I can leave that up. And I think I'm out of time. So I appreciate your attention, and reach out to me if there's anything that we might be able to help you with. Thank you.